Hi and welcome to this Connecting Our Bodies to the Cloud demo. So this demo, it will show a Bluetooth ECG monitoring device connected to a patient capturing system, capturing the raw data and transmitting it to an Android phone. Now the Android phone, it has an application running that collects the raw data and does some basic algorithms to detect when there is a heartbeat. So the main algorithm on the phone detects when there is what we call a QRS complex signal, and this basically represents a good heartbeat. The Android phone, it also acts as a communicator using the transport protocol MQTT to securely and reliably transmit a summary of each individual heartbeat to an Internet of Things application. The IoT, or the Internet of Things application, is based on an open source project called Node-RED. Node-RED is a tool for wiring together hardware devices. In our demo, these hardware devices will be the heart monitors. Node-RED, it provides a browser-based flow editor that makes it easy to wire together flows using a wide range of nodes in the palette. Flows can then be deployed to the runtime in a single click. One of the nodes we're using in the flow represents a Cloudant database. So the Node-RED application, which was deployed from Bluemix, the application we created, we have bound to several services. One of these services was the Cloudant database. Another service is Hadoop. The demo will try and showcase how we can take data from multiple physical devices and then run analytic services in the background to gain some insight from the data. So for this demo, what you're looking at now, this basically represents the Android application. It's running through an Android emulator. Now for this demo, I don't have it actually physically connected yet to the Bluetooth monitoring device. What I'm using is a test record, which is a collection of which represents the raw data. So when I connect, here we can see on the blue line, you can see the raw data. So as I said, there is an algorithm running on the phone, and it's detecting each time there is a healthy heartbeat. Okay, let's now log into Bluemix. I want to show the Node-RED application, and I want to show how it's connected to different services. Because basically the Android application is collecting ECG data. It's performing some algorithms on the phone to detect if there is, or to detect when there is a QRS signal, which represents a heartbeat. It's taking a summary of each of each of these beats. It's adding the physical location of where the mobile phone is, the actual time the beat was taken, and it's sending this information using MQTT, using an MQTT client on the Android phone, and it's sending it to a back-end application. Now the back-end application is a Node-RED application, and Node-RED is then acting as a front end to an Internet of Things or time series database, which is then is checking for an appropriate topic and is then sending it to a Cloudant database. So let's look at that part really. So the data has been sent from the mobile phone and is now arriving at the Node-RED Internet of Things application. So log into Bluemix. here's my application. So the application, this Node-RED application has been written in Node.js. Here we can see I've added a collection of services. The first is of course the Internet of Things time series database, Cloudant database. I also added a Mongo database. I was doing some experimentation with Node-RED and Mongo as well. I've also added the capability within Bluemix to send push notification to the devices. So if we go to the application, go to the editor, I've password protected the Node-RED editor. Okay, so here we can see my Node-RED application. This is the Internet of Things node. Here we can see this is the topic, IoT2 type, Dan's iMac, and the event it's coming in of a format JSON. If I go to the Android code, let me just show you this, where this code gets sent. So on each beat, here we have the Android code. I'm sending the beat to IoT. I'm creating a JSON object, putting in the device ID, putting in the location, putting in the time, putting in the average heart rate. So the algorithms on the phone, I'm calculating, each time there's a beat, I'm calculating what the average heart rate is, and I'm sending this in the snapshot. I'm using a helper class that I've written called MQTT helper. I'm sending the beat. Let's have a look at that MQTT helper class. Here. Now this isn't, I need to improve maybe some of the code here, but basically this helper class allows me to connect to MQTT from the Android phone using a username and password. And then I actually publish the message, create a new message, set the quality of service, and then publish the message. So this is the code running on the Android phone, as we saw here. And this is the topic that's listening. So here, on this topic, I've got a debug node just to show the actual data coming in, the payload coming in. I then have my Cloudant node. Now, if I open my Cloudant node, I can see here in the drop-down list. Here is the service. Now, this drop-down list is filled in with an entry because I have added the Cloudant database here. So this application in Bluemix represents my Node-RED application. One of the nodes is a Cloudant node, and this is represented here. Another example is that Mongo. I've got two Mongo databases. In Node-RED, for example, if I pull a Mongo node, if I configure the Mongo node, here I should see the two Mongo services that are available in Bluemix. So Node-RED is a very, very powerful tool to help us to actually wire Internet of Things applications. So the Cloudant database, that will basically act like our store or our bucket for information that will be coming in from hundreds of connected heart rate devices. Okay, so let's see this in action. So I'll delete this node because I don't want it. Let's just deploy it. If I go back to my application, and if I continue, create a test record, new test record here. In our debug node here, we can see the payload coming in. So we can see that the heart rate mean is changing. The location. Let me just pause this for a second. If I turn on the GPS on the simulator, turn on the GPS on the simulator. The GPS is on. If let's clear this. Let's run a test record again. So here we can now see that the actual location has a GPS location. So the whole idea in the demo is that from a website, from a portal, you'll then be able to actually take these heart rate readings. We'll also be able to display these readings on a Google map. Okay. So once again, these values we're displaying them in debug, but we're also putting them into Cloudant. Okay, let me disconnect here. So if I go back into Bluemix and if I open up the Cloudant database, here in my Cloudant database, I see several databases. Now, in the node for Cloudant in Node-RED, I decided to I put in this entry here. It's called beat location RR. So this represents the database beat location RR. If I look at one of these records here, here we can see this happened on, this is the time in milliseconds, this is the actual device ID, this is basically the MAC address for the Android phone sending. The location here is 0000, I didn't have the GPS turned on. So this really, Cloudant is acting as the data store for all of the different connected devices. Okay. Okay, the next thing I want to talk about, the analytics that we're doing in the background. So to do the analytics, we're using a programming or a statistical programming language that's used by in SPSS. It's a programming language called R. It's used a lot by statisticians, and it's used a lot in the to do analytics. And there is an open source R package called HRV, heart rate variability. And in the analysis of heart and heart problems, they use a lot of sophisticated algorithms, things like fast Fourier transforms, to detect if there's any potential problems in a heart rate. And so we've taken this particular package from here. So it's called, if you hit This is the project. It's called R heart rate variability. So this particular project, it's an open source package for the R environment that contains a complete set of tools for heart rate variability analysis. So the IDE we use is RStudio. I've been experimenting with the different types of the different algorithms. But we actually then wanted to take some of these algorithms and we wanted to run them in a website. So there is an R package called Shiny, which has also come from the people at RStudio, and it allows you to take these R programs and run them in a website. So I've taken this. So if I run the application, okay. So here, this represents the back-end web application. It's going to be doing the analytics. So here I'm connecting to the analytics warehouse. So this analytics warehouse has actually synced with Cloudant. And I'm using a device search here. So if I type in DAN, this will change. There's nothing in it. So I need to put in the MAC address of the device. So we can see when I put in 08, this comes up with the MAC address, the device ID here for my phone. Here we can see the different heart rate averages. This is also come from the phone. The location is the same pretty much. So the whole idea is when this is actually running on a physical device, each beat we can track the location of the device. And here is in milliseconds the time the beat happened. With heart rate variability, the actual time in milliseconds is really important when the beat happened, because what we do is we create an event or we create an episode each time a correct or a QRS beat happens, and the HRV algorithms are basically detecting over time how much variability has happened between each healthy heartbeat. So that's basically the basics behind the analytics. The ECG itself, where we have the ability also to take, if somebody detects a problem, we're also using a REST call. We can send 1 hour or 2 hours of the actual raw data. So the idea here is that we can actually change. We can zoom in as to. Here we can see the actual QRS signal that has come from the actual raw data on the phone. Now all of these tabs represent different algorithms. This is the first one, runs. It's a non-interpolated heart rate over time on the actual signal. Here we're running another algorithm to do some what we call correlation dimension analysis. Computing the embedding dimension, correlation sum versus radius, and local slopes of the correlation sum versus radius. So this type of information is used by heart specialists to detect if there is potential problems with the heart rate over time. Sample entropy is another one of the algorithms that has come from this RHRV project. You can see the correlation sum versus radius, local slopes over time. Okay. So a lot of these algorithms are very sophisticated, quite complicated, require a deep understanding of of heart analysis. But we're hoping that this type of information and quickly be able to analyze this information dynamically will be of use in the healthcare industry. Finally, we have a map of where the devices are. Now, because this is running from a simulator, the GPS of the simulator here is based up in Iceland, in Dalvik. But the idea in the future is that we can track over time to see as somebody is going through, as somebody is moving about through the day, how much activity. When we take samples, has there been activity? Okay, so that's end to the demo. So what I wanted to show was in summary, Bluetooth device connected via Bluetooth to an Android phone. The Android phone has some basic algorithms on it to detect when there is what we call a QRS signal, which represents a physical heartbeat. We're taking a summary of that heartbeat. We're adding the physical location of where the heartbeat took place. We're also adding the actual physical time that the heartbeat took place, and we're sending this to a back-end application. The back-end application is a Node-RED application. The Node-RED application has been provisioned using Bluemix, and we're using we're using a collection of services that are available in Bluemix to take the MQTT event that has arrived, and then we're actually sending it to different nodes. One of the nodes is a Cloudant database. In Bluemix, we have some different services. One of the services we're using is a Hadoop. Another one is the Analytics Warehouse, and we're using some of the syncing capabilities between Cloudant and the Analytics Warehouse and Hadoop. And then we're plugging in using things like SPSS or using something like RStudio. We're building websites then to do real-time analysis, analytics using these algorithms that we've taken from projects like the RHRV project, running them in real time to produce graphs, heart rate analysis, non-linear analysis, sample entropy analysis, Lyapunov analysis on the data. We can also give a map as to where the actual patient and where these heartbeats were happening. Okay, I hope that was of use. Thanks for your time.